Hello, I'm Pluto. I made a Godot tutorial, a video Godot tutorial, and now I'm gonna react to it, commenting on what I find is relevant, and pausing sometimes to explain what I think is difficult to catch. So yeah, let's go. This is a tutorial for a side-scroller game where we first just create a project, wait for Godot to compile the stuff, and I already made the assets previously. So we have, one second. We have the background, the main character, I named Rolly. We have two enemy types, the duck and the crab. And this icon thing already comes built in with Godot. We are creating our first scene here, the background scene, where I'm gonna make the scrolling background behind, where like in an endless runner, the background needs to be constantly, without seams, looping on itself. Since it's pixel art, we have to go to the project settings, textures, and change the setting to nearest, or else it's gonna be all blurry. See, now it's nice and thing. We're gonna put a camera 2D and increase the zoom. Since it's a pixel art, we have low resolution, so we're gonna increase the zoom to 5 by 5 times. We're duplicating the repeating trees, so we have the background that's here and the background that's coming forward. You're gonna know what I'm talking about in a bit. So we made a script, and in the script we have the repeating trees and the other repeating trees, and then we're coding a bit. We're making their position scroll to the left, meaning position point x dot x minus equal delta, because negative is to the left and positive is to the right. And since we want it going left, we want it to be negative. We're doing it to both of the trees, and then we're taking and readjusting the two backgrounds so they line up properly. Okay, now we have the positions. That's 240 pixels, and by that we can make the logic that's gonna make the looping happen. We just check if the rightmost background has reached position 0, and if so, we reset them both so they can keep scrolling. And we're just coding that right now. So they snap 240 pixels to the right every time they reach the thing. As you can see, the recording may be a bit choppy, but in game is smooth and no seam lines. Okay, so now we're gonna make the game root, yes, where we're gonna place the background, our main character, and our obstacles. First off, the background with the camera and stuff, and then we're adding two more node2ds. Obstacles, and we're gonna start off working on them. So we're first gonna do the crab. That's just a land obstacle that spawns in and rolls along the screen. We're changing the position, normalizing it, and then making it so it the position 0 is where the ground is, so it's standing a bit above the ground, not clipping through it. We're gonna do this whole logic stuff without physics, so it's just numbers and things. You don't need to worry about body collision and clipping and stuff. Here we make so that all the children nodes in obstacles are moved just like the background. They scroll right, so they get the delta and they subtract it from their x position. And if the position is too right, meaning they already went off screen, we just delete it, so we don't have an infinite number of obstacles. Here we have the spawn cycle. That's the function that's gonna keep spawning new enemies. It's gonna call upon itself, so it keeps looping, but on a delay. so it doesn't crash our game. We make a new obstacle that's Krabby, since we already made Krabby. We don't need any code on Krabby since it's just a static obstacle that the obstacle node is gonna move, and we set the position to 250. This is things I did before. I decided to go with the randomized range after, so in a bit I'm gonna delete this, just so it's consistent for testing at first, and then we can add the random element. Yeah, just like that. And with the position done, we're gonna wait. This is a way to make the code pause for a moment. This await get read create timer 2 seconds upon timeout, meaning the code stops at line 20, waits for 2 seconds, and then keeps going. And it calls the spawn cycle. Wait. And it calls the spawn cycle. So it like the spawn cycle gets called on once the scene starts, meaning the ready, and the spawn cycle spawns an obstacle, meaning the crab, because that's the only one you have ready. It sets the position, waits 2 seconds, and calls itself. So it keeps calling and keeps doing stuff. And the ready meaning this cycle starts once the scene gets loaded. Oh yeah, and I changed the position to be minus 150. Since they're moving to the left side of the screen, it's going to the negatives. So when they are past like minus 100, minus 150, we can be sure they're like already outside the screen, so we can delete them safely. Playing the scene, we can see that the crab is a bit too big, but it's working. It's correctly spawning in the obstacles. So we just made it so the obstacle scale gets halved. Time is equal 0.5, meaning it will be half as big. Or like 4 times as big, because both coordinates are being halved. Now we're adding back the random element of like how far along they're gonna spawn. They're gonna have like a 20 pixel allowance, so they can spawn a bit forward and a bit backwards. It's difficult to notice at first, but in game it's the randomized elements really matter. And now we're gonna make the main character, I think. Yeah, the Rolly. Save it as a scene, and we're dragging it here. So we positioned it like the Krabby, as to the 0 coordinate be the bottom. So like we can position the 0 coordinate on the ground and know that it won't go past it. And we make a script. Okay, here in the script, we're gonna make it so it keeps rolling, because it's a ball. It's an artistic choice. I decided to not go with animation, as that's like a bit too much for a small tutorial. So I just made it so it rolls around a single sprite. We instantiate the child node, Rolly, and drag Rolly to the position we want it to be. That's it. And there we go. It's rolling around. It still doesn't collide or it does anything. We can't even control it. But right now I'm changing the scale because I found it a bit too big. Yeah, 0.6. Okay, now it seems like a more appropriate thing. We're gonna code now the movement, I feel. Yeah, we're just deleting the comments. Anything besides a hashtag doesn't run in game, we just use it to organize code. And here we're gonna set our constant jump force, jump speed, how high we can jump. And this speed is only since the game is moving the world to the left, our character is actually standing still. We're not moving it. So the only speed we need to get track of is the jumping, like up and down, not right and left. That's something the background and the obstacles are being taken care of. So we only need the vertical speed. and the grounded, so we can know if it's like on the ground. Yeah. If it's not grounded, we're gonna make it accelerate towards the ground, meaning, yeah, it falls down. Roll point position point y or dot y plus equal speed. So the it's something I haven't explained in the game root or the background, but like the position x is horizontal and y is vertical, and as I explained in the background, the minus is left and the plus is right, meaning the way we read in the Western world, and the y position is like minus up and plus is down. So since we want it to fall, we're adding it to the speed that's like being accelerated by the delta. Oh yeah, and the delta is just the amount of time that goes on in between frames. Since different machines have different different running speeds, we're not sure if the frames are being processed in the same speed. One frame may be like 0.01 seconds and another one may be 0.02 seconds. So that it doesn't do the same thing each frame, with each frame being different, we're adjusting to it. This is what the delta is. It's just the amount of time in seconds that it has been since the previous frame. So like here, if we're on a faster PC, each frame is moving slightly less than the previous one. Okay, I'm back. Where was I? Yeah, I was explaining what the delta was, and I felt like I did it. So here we're gonna do a check grounded function that's gonna like adjust our logic to if it's on the ground and if it isn't on the ground. If our rolling position is greater or equal to our like normal state, you can see here that minus 9 pixels in the y coordinates is how it is like hovering above the ground. So we know that if it is greater than that, no, greater? Yeah, meaning it's like falling. Yeah, so this is like making contact with the ground. Is it? Wait, I don't remember my own logic. If rolly will I change this? Shouldn't it be like lower? Oh no, lower is up. Stupid. So if it's greater than this, meaning if it's below the ground or at ground level and the speed higher than 0, meaning it's like currently still falling, we made it so it doesn't fall. We made it so it's grounded and the speed equals 0 and the position gets normalized to 0. And here it's only falling if it is grounded, so this handles that. And then we check ground to see if it is falling. And then we need the input to make it jump. Input. This is the first time in the code we're showing how to handle inputs. We have this input function in Godot that lets us handle input events. The event is called in as a parameter, and it has this function isActionPressed. So in this game, we're making it so it jumps on spacebar, and Godot has a few default inputs, and the UI accept is the name for the spacebar input. So if we press space and it's grounded, we made it so the speed equals the jump speed, the jump constant. And we made it so it's not grounded. Okay. Testing, we can see that it works. Every time we press space, the vertical speed goes to minus 25, meaning it goes up because negative is up. And then it starts accelerating downwards because it's not grounded, and that's being handled on our process, meaning it's getting called every frame. And every time it reaches the ground position, it becomes grounded again and stops going down. Now we're gonna handle the ground slam. Is a thing that some of these endless runners have, instead of a duck, I'm making a ground slam so it goes to the ground faster and we can maneuver better. So this is UI down, meaning the down arrow on the keyboard. And so if we press the UI down and we're not grounded, we can make it so it just speeds up to towards the ground. Speed 50 meaning it's positive, and we can see here that it just snaps back to the ground, falling rapidly. No complicated code for that. Okay. Here in game root, we're gonna make the script for the script for the game root, where we're gonna have a game speed variable. This is so we can make the game speed up as the more time passes and it gets harder. So game speed plus equals delta divided by 20. This just means that it's consistent between different computers with different processing capabilities, I don't know. And divided by 20, we just make it so it's a really small number, because in a bit you'll see that I'll take off the times 20 just to see how fast it speeds up. And since all the background, the rolly, and the obstacles are child nodes of the game root that has the game speed variable, we can just reference it as a variable of a parent. So we can come here and get parent, time, point, game speed. So what are we doing? This is the obstacle. So the code that makes the obstacle go from the right side of the screen to the left side of the screen. We're just multiplying it by the game speed so that as the game speeds up, it does that motion faster. And we're doing that on other places, on Ctrl-C, Ctrl-V. Here, we're making it so instead of multiplying, we're dividing it by the game speed, so it takes less time between the summons. Like, it summons an obstacle, and since it's going faster, it needs to summon another one sooner, so we're dividing it by it. And in rolling, we're making just, it's purely visual. We're making it so it also rolls around as the ground goes faster. After doing all that, we can see that the game starts off pretty slow, but we can already see changes in the speed going faster and faster. Yeah. Okay, now we're doing the second enemy type, I feel. The duck. Saving it as a scene. So the duck, unlike the crab that's just a sprite, and unlike the rolly that's just a spinning sprite, the duck is gonna be an animated sprite. So we come here in spawning as a node, and we go to the sprite frames property and select as new sprite frames. Click it, and we go to this like tab that opens. In here, we can import from our sprite sheet, add frames from sprite sheet, and select our sprite sheet that we made previously. And we're gonna slice up the sprite sheet to the number of sprites we actually have, controlling the horizontal and vertical divisions. So we have only two things, and blah, blah, blah. Yeah. Yeah, so this makes it so as soon as the node is instantiated, it starts playing this animation. It's the setup animation. We may have multiple animations here, like the default running animation. This is just the default animation. Makes it so this animation plays as soon as the node is instantiated. This here is the loop, meaning as soon as the animation goes to the last frame, it comes back to the first one, meaning 0, and it keeps on going. And if we play, we can see that it's a bit too fast. We can change the frames per second, so it's as we went. Yeah, 3 frames seems better. We pause the animation and save it as a scene. Okay, so we can instantiate it later. We made the duck script because unlike the Krabby, the duck is gonna have a behavior. It's either gonna be facing left or facing right, and it's gonna move towards that direction. So here we have the orientation that we just start off as 1, but as soon as the node is instantiated, we randomize that. You're gonna see animated sprite to deep on position equals to a random range position.y, meaning the same logic that's gonna spawn the Krabby is gonna spawn the duck, meaning both are gonna spawn in the ground. So here we're gonna make it so this animated sprite, that's it, the image of the duck, gets the position changed so it is airborne and it can go on different heights. So here we have a randomized range that it can be -100 to -30. Yeah, remembering that it has to, I don't know if any errors come out of it if we don't do lower to higher, but since we just gotta remember that like the lower the number, the higher the thing is on the screen. So it can go to -100, I think it's up here, to -30 with it. It's pretty close to the ground. And we're gonna randomize the orientation. Here we're making an array with the possible values, that's just 1 and -1. And we're gonna pick random from the array. It's a pretty cool way of doing that. Animated sprite to d scale equals to orientation, meaning the scale point x can be inverted. So like the duck is facing one way, and if we set it to negative, it's facing the other way. I think I showed this. Yeah, like transform, we unbind the scale so we can change one without affecting the other. If we didn't break this chain, if I change this to -1, the y would also change to -1. So since we broke this, just to demonstrate how it looks being inverted, like 1 and make it -1, the duck is facing the other way, and then we put it back to normal. Okay, so here we just give the orientation 1 or -1 and make it so it faces the way the orientation is facing. And in the process, we're gonna make it so it moves based on the orientation. We make it so the position point x equals to, no, it's minus the delta times orientation, meaning it's moving based on the delta, and the orientation makes it like move to the left or to the right. Now we're making it so the obstacles, this is the obstacle script, spawns not only crabs but ducks. We're gonna make a similar thing to the orientation picking. We're making an array with both of the possible things and the duck, and make it pick randomly. Pick random, yes. So now it chooses randomly between the duck and the crab. Here you can see that the duck is moving. Yeah, and the duck, when it's facing the other way, it's moving quicker in relation to us. So one has like a more lingering hitbox, while the other is more reaction speed based. And as you saw, they came at different heights. So here we're gonna have a global script named global, just to keep so all of the different scripts can reference this variable without it actually being like connected to it in any way. The thing we do to make it global is go in project settings and go to globals, and here we can set a script to be our global script. We made it so it's our global, and add. So this meaning that in any other script we can call in global with written like this, the G uppercase, and we can reference the alive variable. This is so the game knows like when to stop. We're gonna use it in a moment. Right now we're setting up the hitboxes, so the collisions between the rolly and the obstacles gets detected. We made an area 2D, that's a node to control like collision between shapes, and the collision shape only like determines the shape of the area 2D. We went here on the shape, selected new circle shape since this is a circle, and we're like setting the size. Pretty good size. And we're gonna do the same. Yeah, we are gonna set the collision layers, I think. No. Yeah, first the code, then the collision layers. We're connecting it to the Rolly code. That's our main root. And we're gonna say like, as soon as this touches anything, we're dead. At least for the start. Global point alive equals false. And we can ignore what area it is, what touches it, doesn't matter. If it gets touched, it dies. So we can put an like underscore in it, underline, not underscore, and we can print something. Print die. Now we set the collision layers. So how do collision layers work? How is their logic? Each physics object, this I don't think is a physics object because it's not physics based, it's just detects intersection things. It has a collision layer and a collision mask, meaning it can the layers it can be detected in and the layers it keeps detecting in. So also it has the monitoring and monitorable, because an area 2D can like detect if something enters it, and the other area 2D is gonna be detected if something enters it. Since we're handling the death only in the main character, we don't need it to be detected by anything. We just need it detecting something. So we keep the mask on, so it detects things at the collision layer 1, and we're gonna make it so the obstacles don't detect anything, but they can be detected. Here we make area 2Ds with collision shapes. We make it a square, rectangle, sorry, and then just the shape, and we then change the collision layer so that it doesn't detect, it just is detected. We copy this and paste on duck since they have a similar shape. It doesn't really matter. And playing the game, we can see that it works. Yeah. Right now, we don't do anything to handle how dying works. It just detects that it did die. So next step is making so the game stops running after things stop. Like after the player character dies. So if not global alive, we make it so it just ignores. Like this return thing means that like once process gets called every frame, it means that it skips the rest of the code. We could, in other like functions, we could return a value by calling a function, but this is not something that we do in this tutorial, so I'm not gonna really dive into it. We copy and paste it all over the code so that like here we do it so the duck stops flying once the player dies. Here we make it so the game stops speeding up once the player dies. In the obstacles, we make it so it stops moving the children. No, it stops spawning and stops moving the children once the player dies. Here it just like breaks the chain. So like it's going to here, waiting a bit, then keep going. And if the player is dead, it's just, instead of calling itself again, it just stops. And the rolly, we make it so it stops spinning once the player dies. This should be enough. Yeah, once it collides with something, it detects the collision, prints, and then the player dice. And here I'm checking if it works the same way with the duck, and it does. Yeah. Now we're making an input event to like see if we press space while the player is dead, it just restarts the scene. Like if we press space and the player is not alive, we get 3 point reload current scene. So what does this mean? Godot works on a node-based system. Every node has a parent besides the root node, and the whole tree of nodes and roots and like branches is called the tree. So here we can reference it by this global function get tree point reload current scene, meaning the root of the scene we we are, it gets created again. Like it stops existing and starts existing again instantaneously, just like if we close the game and open it again. So yeah, we die, press space, we're at the start again. But I forgot to make it so the global variable alive is alive again, so the game restarts but the player is already dead. So here we make it so the global point alive equals true. Yeah. Now we can properly respawn. Just like that. And everything else works. So yeah, right now it's like the game loop itself is done. If you want to stop here, you can. But I added a few extra things, such as a life system, where you can have up to 3 lives and get hit 3 times before dying. In the score system, where like you can see how far you went. So let me explain a bit. This label node is a control type node, meaning it's green, and it works differently than the node 2D objects. It's a bit finicky, especially when working in low resolution like this, because as you saw, the text is sorry, all pixelated. So we end up having to change the property font size of the label so it gets big and all nice resolution, but then we have to scale it down so it gets like to the size we want it, but still keeping the higher resolution. Transform, and then as the node 2D, the label also has the transform tab where it has like rotation, scale, position, size, and here we're gonna change the scale to a tenth of, no, 2/10 of what it was, so that it's nice and detailed. And we're gonna change the font color to black since the background is like light, so it's more easier on the eyes. And we're gonna make, oh, so yeah, this is interesting. As you saw, all of these nodes have each of them have scripts, and the scripts are a separate file here on our game's files. And it may get a bit messy to have like 1,000 scenes and 1,000 sprites and 1,000 scripts and 1,000 other stuff. So in here we can make a script, a built-in script, meaning the script and the properties are on the node itself, and it doesn't become a file on our files. Meaning we can't like assign the script to other things. Like if I wanted another rolly with the same code as this rolly, I could just grab the script and drag it here. But since this is built in, I wouldn't be able to do that. Since this is like a label, we don't need this flexibility, so we can just make it built in so it's easier to organize. And since it's built in, we don't need to give it a name. We can if we want to, but we don't need to. And built-in scripts are like this hollowed out engine. Here we're keeping the score that starts at 0, and if the player is still alive, we make the score go up times equal delta. So this is the score, but the label has a property that text, meaning the score is just a inside variable in the script, but the label has a property that is a string property, not a number. So here we make a string conversion from the integer, meaning like, okay, the score is being increased by the delta. That is a very low, like 0 point something something ugly number, let's say. And here we convert it to an integer, so it's just like the naturals, since we don't need it going, not the naturals, the whole number, you know. And here we transfer it to text. But if we do it like that, we make it that it like doesn't have the same formatting as we currently have. That's like 0000. As soon as it starts, it goes to 0 and then 1, not the padding 0. So here we're gonna add the point pad zeros with the number of zeros we want. There's a specific function in Godot just for that. Yeah, so now it keeps track. And here we make it so it gains more score the longer you've been alive. So the score you gain is based on the game speed, like all the other aspects. And it's difficult to see at first, but if you live on long enough, you're gonna see that the score gain keeps increasing. Okay. Here, okay, yeah, the other thing I said, the health value, so it can take more than one hit. This is a bit interesting that this system can be adapted into many other types of games. We're gonna have our HP value and our vulnerable, like boolean, and our blink function. So what's the blink function? If you've played one of the classic Marios, once he got damaged, he like uh, started blinking, becoming transparent, and then reappearing again for a few fraction of a second before he can be hit again. So he just doesn't get comboed, like being hit 3 times in a single second and dies instantly. So here we're gonna make that a separate function so that we can organize our code better, and it's gonna handle the whole of the damaging stuff. So here we're gonna make a for loop that goes to from 0 to 19. This is what this means. We're creating a variable for I in 20, but we don't necessarily need to use the variable inside the for loop. This is just so this code that's in the indentation gets repeated 20 times. And here we're waiting a bit before it gets like vulnerable again. This visible equals to not visible, meaning it alternates between being visible and being invisible. So it being, since we're repeating it 20 times, and it's an even number, it becomes visible at the end, you know. And here, after awaiting the 20 times 0.05 seconds, that is like 1 second, I think, we make it so it's vulnerable again, so it can take damage again. And here, this is a shortened way of saying, like, if HP is different than 0, in Godot, certain values beside the Boolean variables can be interpreted into Boolean. So, like, in numbers, every number that's not 0 is considered true, and 0 is considered false. So here, we're checking, like, if it has HP, that means if the HP is not 0, we make it so it blinks. And if the HP is 0, meaning else, we make it so it dies. And remove the print because it's useless. Testing it, we can see that it blinks, and then dies. Yeah. In this, yeah, I forgot to add the thing to check if it's vulnerable when it's like taking damage, but it's something I'm gonna do later. The lives thing, I'm just gonna use the same sprite as the main character, so to like save time. In the lives node, that's just UI elements, and copy it 3 times because we have 3 lives, and organize it so we like 3 in a row. Excuse me. Speed up. I should have cut off this part in the editing. Okay. And we're gonna reduce the size a bit so it doesn't take as much of the screen, and make it go to the top right corner. Here we're gonna make it so we have a script to set the lives. I made it so specifically this first node is the leftmost row lead, this second is the middle, and this third is the rightmost, so that it loses life in that order, or in that order. And here we have the set lives function, so that it updates the UI. This n is a parameter, meaning when we call it, we say what's the value, and this getChildPointVisible equals false. Okay, so what is this getChild? Every node may have children, and these children have indexes, starting at 0. Since we have 3 nodes, and we're setting life to like 2, we know that like this is 0, this is 1, and this is 2, even though it's a third. The index is 2. We don't have to change the number, it's convenient like that. And we grab the third, meaning index 2, since we're setting the life to 2, and the third one goes invisible. Then, once we set lives to 1, we grab the index 1, and the second one goes invisible. And once we set life to 0, we grab the first one, meaning index 0, and the third life goes invisible, meaning we keep losing the lives as the player gets damaged. We reference the lives in the Rolly code. Yeah, I forgot to say that. I should have said that much earlier. When creating these references to in the code to nodes in the tree, you drag the node from like the scene inspector while holding shift, I think, or control. I don't have in my mind right now. But yeah, so it automatically creates this variable that references the node and all the correct things. And here we're gonna make it so it updates the lives value. Lives.set lives point HP, meaning our HP value. So as we get damaged, the little icons start to disappear, and then we die. Yeah, that's working. And that's what I was talking about. So if it's not vulnerable, we just return, meaning it ignores the functions and doesn't get damaged while it's still blinking. Here are some adjustments I made that like this makes it so the time between obstacle spawnings it's random. It can be 0.7 times or 1.3 times the original time, that's 2 seconds. And we made it so the game scales up faster. This asterisk, these 2 little things, meaning it's to the power of. So we're making the game speed to the power of 2, meaning the faster it goes, the more obstacles will spawn, so it gets more difficult. I think these last moments are just me playing the game. So yeah, you made a Godot Endless Runner. I hope this was useful to you and made you gain interest in the engine and maybe make your own personal project. Shout out to Jax, that's my friend that was trying to do a game in Godot and got a tutorial that wasn't very helpful, and I got pissed off enough and I said like, no, I'm gonna do a tutorial, and here I am doing a tutorial. It turns out it's way harder to do a tutorial than I expected, so this might be a little shitty, but I did my best, so thank you for watching.